All right, we're going to start section 2.2 today, which is direct variation. The equation that I would like for you to write down for direct variation is y equals k times a, where k is just the constant or the slope. Now, for this first example, it says determine whether y varies directly with x. If so, what is that constant of variation? So notice how they have y varies directly with x. And anytime that y varies directly with x, we're going to be using this equation, y equals kx. So we know to start off with, we want to use that equation. Okay, now for this first problem, they're giving you a table, a t-chart of x and y values. We want to see, does y vary directly with x? So we're using this equation, y equals k times x. Now instead of plugging this x in for this x, this y in for this y, what I would do is get this k by itself. So to do that, they're multiplying, so I'm going to divide both sides by x. When I divide both sides by x, these x's cancel out and I get k equals y divided by x. Now this is going to be a lot easier because I want to solve for that constant to see each time that I plug these x and y values in, do I get the same constant? So if I take my y divided by my x's, so 2 divided by 1, 6 divided by 3, 8 divided by 4, do they reduce down to the same number? So when I reduce these, I get 2 here, 2 here, and 2 here. So my constant, my k, would be 2. So I would say yes, y varies directly with x, and then my constant variation would be 2, so my new equation would be y equals 2x, that I would plug that 2 in for my k. Now let's try another example. So number 2, I'm giving you a new table. Okay, so I'm going to plug in these x's and y's into this y divided by my x to solve for my constant. So I have 4 divided by 1, 8 divided by 2, 11 divided by 3. Now when I reduce these, they don't all reduce down to the same number. I get 4 here, and this does not reduce down to 4. So it would be no, y does not vary directly with x. And then since it's not reducing down to the same number, I can't solve for my k, my constant of variation, so I'm not going to be able to answer the rest of the problem. Now this next one, okay, I'm taking my y divided by my x's. Notice when I make these, negative 21 divided by 3, negative 14 divided by 2, negative 7 divided by 1, they all reduce down to negative 7. So this one, y does vary directly with x, and then my constant variation is negative 7, and my new equation would be y equals negative 7x. Now, this next type of problem is identifying the direct variation from equations. So I am going to be giving you equations now instead of a table, and I want to see, does y vary directly with x? So what I would like for you to do on this one is get the y by itself and see if it's in the form of y equals kx. So if my equation is, in this first one, 3y equals 7x, to get that y by itself, notice how they're multiplying, so I need to go ahead and divide. So I go ahead and divide both sides by 3. My 3's are going to cancel out on the left-hand side, so then I'm left with y equals 7/3 x. Notice how it's in the form of y equals kx. So I would say yes, it is a direct variation one because it's in the form of y equals kx, and my k would be 7/3. And your k is just whatever the number is in front of your x. Now to be a direct variation, I can't have any exponents. I couldn't have any numbers added or subtracted at the end. If I did, then it would be no, not a direct variation. It has to be in that exact form, y equals a number and then times x. So let's try another one. If my equation is 7y equals 14x plus 7, I would need to, again, get the y by itself before I can tell. So they're multiplying, so I go ahead and divide both sides by 7. These 7's cancel out. So I get y equals, and then I'm going to divide both of these numbers by 7. So 14x divided by 7 is 2x, 7 divided by 7 is 1. So my new equation is y equals 2x plus 1. This one would be no, it is not a direct variation one because of this +1 at the end. If it didn't have that +1, then it would be yes, a direct variation, and then my constant of variation or my slope would be 2. Alrighty, I have another example for you to try. So the new equation is 5x plus 3y equals 0. So I need to get the y by itself. So I'm going to subtract 5x on both sides. These cancel out, so I get 3y equals negative 5x. Then they're multiplying, so I'm going to go ahead and divide both sides by 3. My 3's cancel out, so I get y equals negative 5/3 x. This one would be yes, it is a direct variation, and my constant of variation is negative 5/3. The next couple examples are going to be use a proportion to solve for the direct variation. So example 1 says y varies directly with x. Y equals 9 when x equals 15. What is y when x equals 21? So for this one, we're going to go part by part. It says y varies directly with x. That first part tells us that we're going to use the equation y equals kx. And then from here it tells us y equals 9 when x equals 15. So we're going to plug those in. And then we have to get that k by itself. So we divide by 15, we'll get k equals 9/15. If you can reduce it, I would go ahead and reduce it. So we get 3/5 because both of these can divide by 3. So we divide the top by 3, we get 3. Divide the bottom by 3, we get 5. So our k is 3/5. Then we substitute that back into the original equation. So we have y equals 3/5 x. So we are done with this step. Now the final step says, what is y when x now equals 21? So we're going to use this new equation that we have. We're going to plug in 21 for our x, and now we're going to solve for our y. So 3/5 times 21. I'm going to make this 21 a fraction, so I can do top times top, bottom times bottom. So I have 63 divided by 5. I can either leave that or I can change it to a decimal. So y would equal 12.6. Or you could have 63/5. Now this second example, same type of problem. It says y varies directly with x. Y equals 15 when x equals 3. What is y when x equals 12? So again, go order by order. If we try to skip to the end, and just plug in this x equals 12. Notice we wouldn't know what y is. We don't know yet what our k is. We would have two missing variables. We wouldn't know how to solve for either. So we need to go in order. So the first step, it says y varies directly with x. So we know we're going to use the equation y equals kx. Second step, we're going to plug in 15 for our y, 3 and for our x. Solve for the k. So divide both sides by 3. These 3's cancel out. We get k equals 5. And then we substitute that back into our original equation, y equals 5x. And then we go to our last step. What is y now when x equals 12? So we plug in 12 for our x, and then we simplify it down to solve for our y. So we'd get 5 times 12 is 60, so y equals 60. Now this third example is more or less like a word problem, but we're going to do exactly the same steps or order as 1 and 2. So it says a salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? So it goes in the same order. Instead of y varies directly with x, it says commission varies directly with sales. So our commission is just our y, and our sales is just our x. So we're going to write that above so it doesn't throw us off. So we're going to use that same equation, y equals k times x. Now it says we have $1,000 in sales, so our sales is our x, so we're going to plug in 1,000 for our x. And then our commission is 85, so we're going to plug that in for our y. And then from here we get our k by itself, so divide by 1,000 on both sides. So 85 divided by 1,000, we get 0.085. And then we're going to plug that back into our original equation, y equals 0.085 times our x. And then there's a follow-up part. It says, what is the commission for $2,300? Now, our commission is what we're trying to solve for, so that we're trying to solve for our y, and $2,300 is our sales, so we plug that in for our x. We go ahead and multiply those, and we get $195.50. Alrighty, the last type of example we're going to talk about in this section is just looking at some graphs. Okay, a couple things that you need to know about direct variation graphs. They're all going to go through the origin 0, 0, and so that k is just our slope. So if I give you the equation y equals 3/4 x, notice it's kind of similar to that y equals mx plus b form, but there's no y-intercept. So our y-intercept is just going to be 0. If I add 0 to the end, it doesn't change the value of the problem. So I'm starting at 0, and then my slope is 3/4. So that's my rise over my run. So I'm going up 3, 1, 2, 3, over 4, and then I can just make that line. If this number is positive, it should be an increasing line. If this number is negative, then it should be a decreasing line. Alrighty, the second and final problem that we're going to go through in this lesson is y equals negative 2x. So again, it doesn't have a number at the end, so we can add 0. So that's our y-intercept. So we start at 0. And then our negative 2 is our slope, or constant of variation. So we make that a fraction, negative 2 over 1. So that's our rise over our run. So it's going down 2 over 1, down 2 over 1. We make that decreasing line, and that would be our final answer. So direct variation equations, just make sure you always remember they go through 0, 0, and then we just use our constant of variation just like a slope. So using rise over run.